right, class, so we're back to go over 10-6 worksheet. And if you haven't watched 10-5, please click out of this video and go back to the assignment on Canvas and click that. But to jump into this assignment, we are still using the quadratic formula, but we're going to simplify a little bit differently. So the goal with the quadratic formula is we use this formula when we can't factor using the X-game method. And so similar to what we did in lesson 10-5, we're going to do our 4 steps. So step 1 is to identify A, B, and Z. So A is equal to -2, B is equal to 6, and C is equal to 9. Step 2 is to plug it into the formula. It's located on your paper. So X is equal to -B, or -6, plus or minus, here comes our long radical, B squared, 6 squared, minus 4, and then we're going to do A times C. So -2 times 9 is -18. All over 2 times our A value, which is -2. So for step 3, we're going to write our square root and simplify it. So 6 squared minus 4 times -18. When we plug that into the calculator, that will give us the square root of 108. As we know from previous units, 108 is not a perfect square. So this is when we have to simplify our radicals. Remember, to simplify our radicals, we can divide by 2, 3, 5, sometimes 6, and 7. So when we take 108 and divide it by 2, that gives us 54. That's not a perfect square. So we're going to take 108 and divide it by 3, and that gives us 36. So square root of 36 times the square root of 3. We do know the square root of 36 is 6, and we don't know the square root of 3, so it stays underneath the radical. This step is important. Here's how we determine that it is different from what we did in the previous video. Because step 3 was not a whole number, when we get to step 4, we will not need to write it as 2 separate equations. So previously, if it was a whole number, we wrote the 2 equations and broke apart the plus minus sign. One of them was -b plus our radical over our fraction, and the other one was -b minus the radical in our fraction. But in this case, because it was a radical that was just simplified, we're going to keep it as x equals still -6 plus or minus that long square root turned into 6 square root of 3, and -2 times 2 is -4. And we're almost done. We're going to take it a step further. We need to look at our whole numbers. -6, 6, and -4. We can reduce all those whole numbers by dividing them by 2. So we will keep our x equals -6 divided by 2 is -3. Keep our plus or minus. 6 divided by 2 is 3. Our square root never changes, so it'll still remain square root of 3. And then -4 divided by 2 gives us -2. This is the simplest form our answer can be in, and you might like it a little bit nicer because we don't have to separate the 2 equations. Next, we want to go on to number 1b. This will be our last example on the front, and any assistance you need, feel free to ask. So again, step 1 is to identify A, B, and C. A is 1, B is 1, and C is -4. Step 2 is we're going to plug it into the formula. So x equals -1 plus or minus our square root, 1 squared minus 4, and then A times C, 1 times -4, gives us -4. All over 2 times A, which is 1. So hopefully at this point, you are able to at least do step 1, which is identifying our coefficients of A, B, and C, and part 2. Step 3 is to simplify the radical. Don't overcomplicate it. The calculator does all the work. You just have to make sure you input everything correctly. 1 squared minus 4 parentheses -4, and the calculator 17 should pop up. We do not use the square root button because in these cases, when we're simplifying, we do not simplify to a whole number. So reduce any error calculations, just do the numbers underneath the square root, and then we can determine if it's a perfect square or needs to be simplified. In this case, 17 is a prime number. We cannot simplify it like we did in A, and so we were going to keep the square root of 17 as our last portion of step 3. Last but not least is step 4. We're still going to keep our x equals -1, but our long radical turned into the square root of 17, and 2 times 1 is 2. There's nothing more for us to simplify because our whole numbers, again, are -1, 1, and 2, and they're already in the simplest form. Please make sure that you take your time when it comes to C and D, because these problems actually a little bit simpler than we did. The only thing you have to watch for is if you need to simplify your radical like we did in A, or you need to simplify the whole numbers in your statement, in your quadratic formula, because you would not see the answer. On the final exam, this would be a multiple choice question, and just make sure you take your time, because formulas are like ingredients, as I stated in class. You have to make sure you're careful what you put in so you get the correct thing. So very quickly, I wanted to give you some tips to help you with the matching on the back of the worksheet. We have our quadratics. These are all polynomials that turn into parabolas when we graph them, but a couple things that people forget about polynomials is a lot of information can be had just by knowing what A, B, and C represent. So we're going to focus on the 2 terms. We're going to look at A and we're going to look at C. A is going to determine if our graph opens up or down. So if A is positive, it will open up. So case in point, number 1 is going to open up. Our U will open up. So it'll be a happy face. If A is negative, it will open down. So number 2 will open downward. So that's something to help you. C is very important because it gives you your y-intercept. The y-intercept is always at the end. So your y-intercept for number 1 is 1. Number 2 is 8. 3 is 4. So that's very helpful. That helps you be able to match your graphs. So looking at A on the graph, and hopefully you can see it better on your paper, I know that this is opening down, meaning A has to be negative. My only options are 2, 4, 6, and 8. But I also see that it crosses through a negative value. It appears to be -5. So I'm looking at either 2, 4, 6, or 8, and I want to look for where my y-intercept is -5. 2, that's not -5. 4 is a -5. But when I get to number 6, I notice that graph A matches all that information. So you don't necessarily have to make tables or plug it in. We're just using deductive reasoning skills. Looking at B, I see that this graph opens up. My only options for graphs opening up are ones where A is positive. So that's only 1, 3, 5, and 7. But I also see that it crosses through -6, which means my y-intercept is -6. So looking at my ending numbers, I only have one option that has A be a positive value and has a y-intercept at -6. So that would be 7. So hopefully this helps. We'll look at one more. C opens down, so our only options left now are either 8, 4, or 2. But I notice that I crossed the y-axis, this is our y-axis, at -1. So between 2, 4, and 8, the only one that has a y-intercept at -1 would be number 4. So that would go with C. So hopefully these helped you. You at least have 3 out of the 8 done, and you can be able to continue and finish it. And if you have any questions, feel free to see me.